Well, welcome. I'm Star Gilmartin, member of the Trenton's Broadband Committee. And this is the third of several training sessions we're organizing and hosting. We will be recording these presentations as well as the Q&As and posting them through the Trenton Town website and YouTube channel. The YouTube channel will be put in the chat line for anyone who is interested. Until June, we plan to hold these at 3 p.m. on the fourth Sunday of each month. The committee wishes to acknowledge and thank the Maine Community Foundation for their grant award supporting our broadband literacy training efforts. And of course, John Whetstone, who is a broadband committee member and an expert on our topic today, hardware. Before we introduce John, another committee member, Saul Goldman, will share a few tips on the Zoom meeting participation. Saul?
Thanks, Star. So in case you're not familiar with Zoom, here are a couple of pointers. One is as you look at the screen on the bottom left of your screen, there's a microphone in which if you're not already muted, you can mute yourself. We do ask that you mute yourself generally just so that we don't pick up background noise. Next to that, there should be a video, like a video camera icon. That we'd like you to actually go ahead and if you're comfortable, keep your video on, just because we're a small group. If you want to rename yourself, there's in the participants, you can find yourself and rename yourself that way. Also, if you have any questions, there are a couple of ways you can ask questions. One way you can ask questions is by, so John's going to be going through the PowerPoint. So at the end of each slide, you can ask a question by either unmuting yourself and just talking, or you can actually physically raise your hand, or under reactions, which is on the bottom menu of your Zoom screen, you can virtually raise your hand. You can also put questions in the chat. So lots of ways to ask questions, and we welcome questions. John welcomes questions, and I'll give it back to you, Star.
Okay, so our presenter today is John Whetstone. He is a communications systems engineer going back to the early 1970s. In his long career, John has had various positions: CTO, chief engineer, vice president and general manager, executive vice president, and principal engineer. He has designed, developed, and managed sophisticated satellite ground systems for major communications and satellite companies during the past several decades. He was an independent contractor consultant on large projects for major companies, including Norsat International, the Red Cross, PBS, as well as the FBI and military branches. John has extensive technical experience with communications hardware, and we're very fortunate he is here to help us understand our communications hardware.
Thank you, Star. That's a great introduction. As she said, I'm John Whetstone, and we'll be going through the last month. We did what the services were, what was available, and so on, and primarily focused on spectrum, although discussed some of the other possibilities. But today we're going to go through the broadband service equipment. This slide is depicting what can be available. And one of the things, we're coming in from spectrum on a coaxial cable, going to a cable modem. Now, usually that is an installation done by Spectrum, and they almost always will provide the cable modem. Sometimes that will be integrated with the Wi-Fi router. That's the way they will provide it. Now they're actually providing them as separate units, a cable modem, which is a box. I'll show you pictures of those, and then a separate Wi-Fi router. And those would be connected via an Ethernet cable. The other function that the cable modem provides is if you are partaking of Spectrum's phone service, that will connect directly into the cable modem with a standard telephone cable with an RJ11 connector on the end of it. If not, that connector is just there, but on their cable modem, it is available for either one or two phones. In this drawing, it shows that the television and computer are connected directly to the Wi-Fi router. That's a capability that the Wi-Fi router provides. But you can also connect them wirelessly through Wi-Fi capability of the Wi-Fi router. The other devices there, laptops, security cameras, smartphones. So again, your laptop, you could plug that directly into the Wi-Fi router using an Ethernet cable or connect it over Wi-Fi, which is probably the more common way to do it. Again, security cameras, those are most always connected wirelessly into the Wi-Fi router, but they, in certain instances, they could be connected directly. Any questions?
So,
Yeah, John, I've got a question.
Yes.
I was trying to figure out what speed I'm actually getting because I wasn't sure whether my router was slowing things down. Can I connect my laptop directly to the modem?
Yes. Absolutely. Yeah.
So just a straight an Ethernet cord from the from the modem right to my laptop, and that way I should, if I do a speed test, I should know exactly what spectrum's sending me. Is that right?
That's correct. There's a single RJ45 connector on the cable modem. Normally that cable would plug into the Wi-Fi router, but you can simply disconnect that and plug your laptop into that and get connectivity and do your speed test. In fact, if there's any concern about the speed, that is where Spectrum, if they come out to investigate, that's where they will connect their test equipment up to, because then it eliminates anything beyond, which could be owned by you, that might be causing the problem.
Okay, thank you.
Okay, what is a cable modem? As I said, the cable modem is usually provided by Spectrum, although in the past, Time Warner Cable was charging for the modem at the rate, it was started out at $3 a month, and by the time it went up to 10, a lot of people bought their own modems in order to avoid that charge, and modems were, at that point in time, were costing $70, $80. But now Spectrum includes the modem with all of their internet service plans. So there's no reason not to have them provide the modem, and really every reason to have them provide it, because then they have to guarantee the speed. Well, I shouldn't say guarantee, but they are supposed to provide the connection speed both up and down to the output of that modem. What does the modem do? It converts the internet service providers, which is Spectrum's radio frequency signals, from the coaxial cable to the digital signals fed to the Wi-Fi router, and that would be over that Ethernet cable. And as I said, it also provides a connection to a telephone if you subscribe to Spectrum's service for that. The cable modem is going to govern the speeds that you connect to or connect at. Spectrum will program the cable modem based on what you're paying for. The standard now in Trenton is 200 megabit down and 10 megabit up if you are a Spectrum customer. If you're a legacy customer, that can would generally be somewhat less than that. Say, usually they're doing 30 megabit up and 5 megabit, 30 megabit down and 5 megabit up. One of the issues with the modems, they are have to be compliant and are compliant with what's called DOCSIS, which is Data Over Cable Service Interface Specification. And on the label on the modem, it will say what the DOCSIS number is. And currently, they're 3.0 or 3.1, 3.1 being the latest that's currently available from Spectrum. That offers some faster speeds and a little bit better performance than DOCSIS 3.0. So if you see that your label says that it's DOCSIS 3.0, you can actually trade that unit in to Spectrum for the latest version, 3.1. There's some pictures of cable modems. It's the same modem in the picture. There's a front one showing Spectrum. The middle picture shows the connection. And in this case, the two connections up towards the top of that with the white connectors are for telephone. In this case, there's one telephone connection to that. The next one down below in the middle part of it says cable, and that's where the coaxial cable would connect to. The next one is the Ethernet connection going from there to the Wi-Fi router. And the very next one, which you can hardly see, is the power input to the Spectrum modem. The next picture shows a little bit more of where the cables are coming from. Standard for Spectrum, there's a device there that's just a pass-through, and you can see a green cable. That's a ground connection, which must be connected, and that sometimes can be outside the house, or in this case, it was inside. And then there's a coaxial cable that connects it up to a device called a splitter, which allows them to have a convenient test point for measuring the RF levels coming in over that cable. And then the other cable just snakes around and goes into the cable modem. So it's a very simple setup, just involving coaxial cable to the modem. Any questions? Okay, a Wi-Fi router, that's the next device in the chain. That communicates between the cable modem, which is providing the internet, and the devices in your home. And that can, as I said before, that can either be through Ethernet cables, or it can be wirelessly, and that's generally how it's done. In some cases, that Wi-Fi router is integrated or can be integrated with the cable modem. That was the way that Spectrum used to provide it as a standard, and I think they're generally getting away from that now. It connects via Ethernet cable to the cable modem if the units are separate. And as I said, it can provide several hardwired Ethernet connections as well as Wi-Fi wireless connection. But part of the functionality of a Wi-Fi router provides us a firewall which provides security for your equipment across the internet. And Wi-Fi router ideally should be placed in a central location to provide the best wireless coverage. And that's one of the reasons for having it separate from the cable modem. It's easier to run Ethernet cable than it is to run coaxial cable. And there are losses, the longer the coaxial cable is, there are losses associated with that, which may affect the performance of your internet connection. So, as I said, it's best to have them separate. And that would then allow you more flexibility to locate the Wi-Fi router in an optimum location. Continuing on with the Wi-Fi router, the Wi-Fi routers do support two bands, the 2.4 gigahertz Wi-Fi band and a 5 gigahertz band. The 2.4 gigahertz, because of its lower frequency, has a longer range within your home. It can pass through walls better than the 5 gigahertz signal can. But because of limited bandwidth in the 2.4 gigahertz band, the speeds are slower than they are at 5 gigahertz. There's just, with 5 gigahertz, there's more bandwidth available. The wired Ethernet connection, because it's directly connected to the Wi-Fi router, not using Wi-Fi, actually provides the fastest speeds. And you should not notice any difference between the speed coming out of the cable modem and coming out of the Wi-Fi router Ethernet connections. There are several versions out there now, Wi-Fi routers. There's an IEEE, which is an international organization. They have a standard called 802.11 that's been around for many years. The most common routers today adhere to 802.11n, which is also considered Wi-Fi 4. That's the slowest and oldest of the group. Most common ones now are 802.11ac, which is Wi-Fi 5. And the latest one commonly available, I'll speak briefly about another one, 802.11ax, which is Wi-Fi 6. There's also a Wi-Fi 6E, which uses a 6 gigahertz band. Those units, they are available. You'll see advertisements for them. They're very expensive and for home use, generally not needed. Many Wi-Fi routers, in addition to having the basic network, will also offer a guest network, which is a separate network. It's isolated from the primary network, which can be used. It would have a different password, may have different security level, so it could be used for your guests. The other thing that it's helpful in is a lot of wireless devices which utilize only the 2.4 gigahertz band, such as security cameras, thermostats, smoke detectors, garage door openers, smart plugs, and so on. They generally will only use the 2.4 gigahertz band, and you could actually put them over to the guest network so that they don't interfere with your primary network. There are Wi-Fi routers currently available which provide mesh connectivity. That would be a Wi-Fi router and then several other units placed around your home which connect together, offering kind of a seamless connection. It's using the same password, the same connectivity. So as you move throughout your home with your cell phone or your laptop, you don't lose connectivity. It stays the same throughout. It just connects to different units as you move throughout your home. A picture, yes.
I have a question. So would that be less secure than, like, if you were, if somebody was staying in your house that wasn't related to you or something, wouldn't you want a more secure?
Well, that would be a good example of using a guest network, assigning them to a guest network with a different password, right. And then they have no connectivity into your network, into the devices. Say if you have a printer that's on your primary network, they would not have access to that, nor any of the other devices on your network. Any other questions?
Hey, John, I have another question. I have a mesh network, and I was just looking at the bottom to look for my IEEE number, and I don't see one at all.
Does it say Wi-Fi 6? Does it say AX in the model number?
None of the above that I can read. It's got an S/N number, an MAC number, and an SSID number.
Okay. Generally, when you go on the website, when you would have ordered those units, they would either, the newer ones are, they specifically will say Wi-Fi 6, and only to differentiate them from Wi-Fi 5. A lot of the Wi-Fi 5 routers simply had AC somewhere in the description, like they would say AC 1900, and that indicated that they were Wi-Fi 5 and they had a throughput speed of 1900 megabits. And that's what I found to be most common, is they would have an AC in the model number. Now they have an AX in the model number, but most of the vendors are differentiating them from the older Wi-Fi 5 by saying that they are Wi-Fi 6. And they're going to be usually more expensive than the older Wi-Fi 5 units. Now, the other thing is, when I stopped at Spectrum, the units that they're providing now, if you buy their separate or pay the additional $5 a month for the Wi-Fi router capability from Spectrum, they are now providing Wi-Fi 6 Wi-Fi routers. So that's the good news. Does that answer the question?
I've got the AC number on this model, so I can look that up.
Okay.
Yeah.
So yours would be, yours is probably Wi-Fi 5.
Yeah, it's an AC 1200. I didn't get the top of the line. Yeah. Okay, thank you.
Yeah, not yet. Okay, so these are commonly what Wi-Fi routers will look like. They generally will have external antennas. That allows you to adjust those antennas to kind of aim in the direction that you want your coverage to be. With those different antennas, they have a capability called beam forming, so they will electronically kind of learn where your devices are. If they're static, like a television with a Wi-Fi adapter to it. But there are other ones that are internal, which I'll show you on the next slide. But this is generally what your Wi-Fi router would look like. The picture over on the right-hand side here, that's one that was being offered by Spectrum, and that's got internal antennas in it, but it also shows the connectivity on the rear of the unit, where you have an Ethernet connection in and then 4 Ethernet outputs. So in addition to the wireless connectivity, you do have the hardwired Ethernet ones. And the one on the left shows the same thing, where the one that has yellow underneath that Ethernet connection, that's the one that connects to the cable modem, and the other 4 are available to connect to devices. So if you've got a Wi-Fi router and it's close to where your computer setup is, it would be advantageous to connect your computer directly to the cable modem rather than connecting over Wi-Fi. That would offer the best, the fastest speeds and the most reliable speeds. Any questions?
I have just a question about, like if you needed an extender and you wanted to extend it outward, is that coming? Okay, there you go.
And John, I had a question. Sometimes on the back of those, there's a WAN port and an LAN port. Is the WAN, is that what connects the modem to the router, and the LAN what you use to connect the Ethernet cable to the device? Is that right?
Yes. There should be a single WLAN, which stands for wide area connection. That's a wide area connection. And the LAN is local area network connection.
Thank you.
And you usually on the mesh systems, they generally will not have 4 connectors, Ethernet connections. They'll have sometimes only 2 or 3, but generally not 4.
Yeah,
Just because the physical size of the mesh units don't allow you to have all 4 of them. How many does yours have?
we have, there are 2 on our units,
Yeah.
which is fine.
Yep. Okay, Wi-Fi router security. This is an important issue. You were saying that on the label on the bottom of your Wi-Fi router, your mesh router, it had an SSID, which is a unique name for your network. It's so that your computer will connect into your network rather than into your neighbor's Wi-Fi network, for instance. There's also Wi-Fi security called WPA2-PSK. That is one of the most current ones. They're doing WPA3 now, but even though the Wi-Fi router may support it, many of your devices don't unless they're newer devices which can support it. If they do, that would be advantageous to use that. That simply is a security that enables people who would be in the area that they're receiving your Wi-Fi signals. They can't break into those signals and monitor them or spoof them. The SSID, as I said, is a unique name. You can turn that off. And if you have devices which are fixed in your network that don't need to see that SSID, or that you can manually program that in when you try to connect that device, you don't have to broadcast that SSID. Broadcasting it means that anybody can see that if they're within range of your Wi-Fi network, such as a neighbor. They'll see your SSID. And that's the reason for setting up a unique password to be able to connect into that network. So even though somebody can see what your network name is, your SSID name, they can't get in unless they have your unique password. Many people, when they get a Wi-Fi router from Spectrum and so on, they'll leave the SSID as a default one as it came from Spectrum, and they'll also leave the password as the one that's printed on the bottom of your mesh Wi-Fi router there. And that obviously is not a good thing to do. It's good when you get your Wi-Fi router to program in your own SSID and definitely program in a unique password.
Mhm.
Yes, Jim?
And so by turning off your SSID, that's the same as what people may say hiding your network.
Yes, absolutely.
Mhm.
Yeah, nobody will see that your network at all. If they look, they may see the carriers, but they come up as being unnamed.
Yeah.
It'll say the word hidden on it if you look.
Yeah. So that's interesting, because like if you go to a hotel or something and it comes up, you look at, you're searching for whatever the name of the, you'll see like a whole bunch of different ones. You're trying to figure out which one should I.
And many of those don't have a unique password because they would be considered a guest network.
Yeah.
So you could set up a guest network with no password.
Yeah.
But the problem with that is then your neighbors or somebody driving in and around can
log in.
Yeah. And I do know some people who will either drive around or walk around and try to connect into Wi-Fi networks that people don't have secured.
Wow.
So,
worrisome.
as I said before, setting up a guest network, you can use that, setting up that network for your security cameras, smart plugs, door locks, thermostats, and so on. And the reason for doing that is that some of those devices, such as security cameras, are storing the video in the cloud, which means that a third party has access to that. And by having that, they have access or could have access into your network if they really wanted to. So by having it on the guest network, that isolates it from your primary network.
Or it could be hacked.
Yes.
Yeah. Wow.
Yeah. Okay, range extender.
There we go.
That's going to extend your Wi-Fi coverage to areas of the home where the Wi-Fi router signals are weak. It's a separate box. Most of them will provide operation in both the 2.4 gigahertz and the 5 gigahertz band. That's considered dual band capability when you look on the internet, on Amazon or whatever to buy an extender. They'll usually have the description dual band capability, which means both 2.4 gigahertz and 5 gigahertz. There are still less expensive extenders available that only cover 2.4 gigahertz. And that would be, those can be utilized where you're simply wanting to extend your Wi-Fi network to a security camera or door lock or garage door opener. So one of the devices that only operates in the 2.4 gigahertz band. And the reason they do that is 2.4 gigahertz band, as I had said before, will penetrate more easily through walls and doors and so on. So they have a longer range within your home to be able to support these devices, which could be located right outside or in your garage or whatever. There are more expensive Wi-Fi extenders that provide a separate link back to the Wi-Fi router using an additional, in most cases, a 5 gigahertz link, and those are called tri-band. And they're more expensive, but they're faster. And the reason that they're faster is they're not using the same band to connect to your device and back to the router. They're connecting to your device over one of the bands, either 2.4 or 5, and then back to the router using another band. And most of the mesh systems do have that third band. So they're communicating in each other and back to the router over a separate frequency band. Well, it's the same band, but a separate channel back to the primary router or mesh network router. Range extenders, the newer ones are Wi-Fi 6 capable. There are older ones that are Wi-Fi 5. The Wi-Fi 6 are faster because they have a wider bandwidth availability. So it's preferable to do Wi-Fi 6, especially now. There's Wi-Fi range extenders, most of them can also be set up as an access point. They all will have a separate Ethernet connection to them. Initially, that Ethernet connection is used to set them up, but once they're set up, that connection can either be used as a direct connection into a device like a computer or a television or whatever that's local, so that you're doing Wi-Fi into the extender, but then an Ethernet cable connection into the device, or they can be used, that port can be used to connect back to the Wi-Fi router. So instead of connecting via Wi-Fi back to the router, they connect via an Ethernet cable. And when they're connected that way or used that way, it's called an access point. So it's, in most cases, it's the same device, although there are some of them that are only access points that do not support Wi-Fi back to the Wi-Fi router. And that's this net, usually range extender has an Ethernet connection or connector that can be used to directly connect equipment. Generally, with a range extender, it's recommended you initially set it up right near your Wi-Fi router, and then you move it to a location which you want to leave it at. And that generally is done halfway between your initial Wi-Fi router and the piece of equipment that you're trying to serve. That's a general rule of thumb on that. And pictures of a couple of range extenders. The one on the left-hand side has internal antennas. That happens to be a Wi-Fi 6 unit. The one on the right has external antennas, and that's a Wi-Fi 5 unit. But there's no written, the external antennas does not mean it's Wi-Fi 5, and internal doesn't mean it's Wi-Fi 6. It's just two pictures. The one on the right-hand side is a less expensive unit. It's only Wi-Fi 5. That also may be only a 2.4 gigahertz unit. Any questions? This is an example of what a range extender can do. These are speed tests that were done right here at the town office. The one on the left-hand side, down in the lower right corner there, it says what the Wi-Fi is, and it says Trenton office connected and secured. So this is the connection that I was measuring from here in the conference room. And you can see the download speed is 13.77 megabits. Upload is 10.80. Not good. In fact, that's one of the reasons why when we were doing Zoom sessions from here that we had dropouts at some times. The speed test on the right-hand side is going through a range extender. It's a Wi-Fi 6 dual band range extender. It connects back into the same device that the speed test on the left is showing, but you can see the speed increase. It's gone up to 86.01 on down and up slightly on the upload speed as well. So that shows you what can be gained by adding a range extender if you are getting poor speed performance within your home. And I'll go over how to test that in a minute here. This is integrated units versus separate cable modem and Wi-Fi router. I spoke briefly about that earlier. Now, as I said, they can provide it as an integrated, but generally now they're providing separate units. They do charge a $5 monthly fee for the Wi-Fi router, regardless of whether it's integrated or separate. So if you want to get away from that $5 fee and provide your own, I personally would recommend that, but anyway. And separate units do give more flexibility to optimally locate, which I had touched on a little bit before. And you can also provide your own Wi-Fi router to save the $5. If you have an integrated unit from Spectrum, you can go to the Spectrum store and swap it out and get the latest cable modem, which is would support DOCSIS 3.1, and also the latest Wi-Fi 6 Wi-Fi router. So if in doubt, the Spectrum store, which is up in Bangor, right next to Bed Bath & Beyond in that same area. The separate units, it's, as I said before, it's advantageous to have the cable modem located where the coaxial cable enters your home rather than extending it. I know we have 2 members of the Broadband Committee that at least who have, well, no, 3 who have extended their coaxial cable to where the cable modem is. So that's satisfactory, but the coaxial cable is generally more expensive than Ethernet cable and a little bit harder to run correctly. Cable modem does require AC power, as does a separate Wi-Fi router. So an integrated unit, it's only one AC power connector to that. And also Ethernet cable is required between the cable modem and the router if they are separate units. Any questions? Yes, Saul.
John, in the house where I live, there used to be a direct TV. We don't have that now, but they ran cable throughout the house. This was a number of years ago, maybe 10 years ago. So a lot of rooms are set up with a cable outlet. If we should at some point want to have cable to this house, is that old cable still good, or has cable itself changed?
There are yes and no. The cable, it depends on what they've run. The cable to the TVs is generally 75 ohm, but it could be small diameter, which has more loss to it than what you would like to have as you go further through. The other thing is that depending upon where those connections are, if it's going through a splitter, which it usually would because it's feeding multiple coaxial cables to the different TV sets that were in the home. So I would generally not recommend that. However, it is a way to get a cable modem further into your home, whereas running Ethernet cable now would be more difficult to do.
Thank you.
All right, I touched on this a little bit, the frequency bands. Most Wi-Fi routers and extenders support both the 2.4 and 5 gigahertz frequency bands. And is it too loud? Okay. Anyway.
You're not too loud, but when he talks, it's very loud.
Just move that, pivot it away. The 2.4 gigahertz band provides better coverage, longer range within the home, as I had said, because it's the lower frequency, it's less susceptible to attenuation due to walls and doors and so on, or going from one floor to the next. But one of the disadvantages of 2.4 gigahertz, it's shared with many other uses. Bluetooth uses the same band. Cordless phones can either generally will use 1.4 gigahertz. Baby monitors, microwave ovens put out a lot of energy in the 2.4 gigahertz band. So their 2.4 gigahertz band is definitely more susceptible to interference than you would have on a 5 gigahertz. But because of the increased frequency, the higher frequency of 5 gigahertz, it has less range. It's more susceptible to attenuation through walls and doors and so on. One of the main things, though, is either band, 2.4 or 5. In your Wi-Fi router, they will come set up for auto, which means that they'll seek out a frequency, a channel, a Wi-Fi channel to use. But in general, it's preferable for you to select one. Excuse me. And there are programs which I will cover, I think, in the next slide, which will depict what channels are being used and show, what your neighbors are using and so on, and will allow you to set your router up to the least used or possibly an unused channel. And that would give you, some interference-free capability. Wi-Fi analyzer applications, there are ones available for Android. Mary's putting up what the links are here. going to show, can you see this on yours, Mary? On your,
Oh, so it's
Oh, wow.
doing, yeah, analysis of.
okay, that's what
Wi-Fi
it looks
signal.
like. So that's
Okay.
showing the 2.4 gigahertz frequency band, Wi-Fi band, and showing the channels that are in use here at the Trenton office. And there is no other interference on the other channels, so that's good. But in general, that would not be the case.
So the darker purple, that would be,
No, those are actually operating on the same
okay,
channel,
all right.
which appears to be channel 11. And there are no others in use. But I'll show you, I've got some slide here that shows what it looks like. But that's one of the Wi-Fi analyzers that I show here or list here. There's another one, which is my favorite, which is Wi-Fi Man. And that will actually show all of the devices which are connected
Uh-huh.
to that network.
That's available for Apple as well.
Yes.
Oh,
And so, and that's a free application. Wi-Fi Man is
Mhm.
free. It's put out by a company called Ubiquity, which makes extenders and all sorts of Wi-Fi equipment, excellent Wi-Fi equipment. And there are ones I've listed here for iPhone and also for PC. And I'll show you this. It's called Wi-Fi Commander. It's $3.99 from the Windows App Store. And I will show you pictures from that. That's also one of my favorites. I didn't list them for Apple because I don't have an Apple. So, but similar applications are available for Apple computers as well.
but you have them for iPhone.
Yes. Just, yeah. I ran out of space on the slide. This is Wi-Fi Commander. This is what the display looks like. This is at a church down in downtown Ellsworth. And so this is showing carriers that are located across the 2.4 gigahertz band, which is here on the lower area. The middle display here is for the lower frequencies in the 5 gigahertz band. And the upper one, this last tier, is for higher frequencies in the 5 gigahertz band. And the names here are coming up. These are the SSID names for each of these. If it shows in gray, these are the hidden channels that are communicating back to other modems and so on. It's also possible that that's a network where their SSID is not being broadcast. So it's showing the carrier there, but it's not showing the SSID. And you can see the way they're arranged here, the higher level ones are towards the back of the row. And this is an easy way to tell, like if you have this Wi-Fi Commander program on your laptop, you can actually walk around your home and see how the level varies from room to room. And also, if you're near a neighbor, if you walk to that side of the house closest to your neighbor, you can see if their Wi-Fi channel increases in level where it might be causing interference on the channel that you're on. So it's best to pick a channel that is not being used or has less use than the others.
John, what is
Yes.
the default channel that comes on most of these? Is it 11?
It generally is 6.
6, okay.
Most of the ones are coming default channel 6. But yeah, I think it's best to choose your own, which you probably have. Any other questions on this? This is showing another program peacefully coexisting with Wi-Fi Commander. The top one is called NetSpot. It's not an inexpensive program, and it is showing a list of the SSID names down on the left-hand side here. BSSID is actually called a MAC address. It's a unique octal code that is, it's unique for every device in the world. There are not supposed to be two of them that are the same. I can't guarantee that. But this is showing what the signal level is in the next column, what band it is operating, 2.4 or 5 gigahertz band. And then just graphing of the levels and so on. It shows what channel is being used. So here, the top one is showing it's using channel 149 plus 1, which means if you look at the next one, it shows that the channel bandwidth is 40 megahertz. And there's a mixture of 40 and 20. This would be the bandwidth of that channel. And obviously, the higher that number, the more throughput you can get with that channel. So the top one is a 5 gigahertz, and it is using a bandwidth of 40 megahertz. The ones below are using 2.4 gigahertz band, and they're only 20 megahertz wide. You'll also see that Trenton Guest network is an open network. So that means it has no security on that network at all. And that doesn't mean that it doesn't have a password. That means it has no security, which is unfortunate. The other thing, the next column here called mode, you can see that the top two units are AX. That means that range extender, that's Trenton Office _EXT, is Wi-Fi 6 capable. The next one down are AC, which is Wi-Fi 5. And then the bottom two are N, which is Wi-Fi 4. So those are the slowest speed units. And they're only 2.4 gigahertz band. They do not, the Wi-Fi 4 does not support the 5 gigahertz band generally. That is the end of the presentation.